sketch 155 degrees in standard position. Then determine the quadrant it terminates in. And the reference angle. So that's number one. Number two, given the reference angle and quadrant, determine the angle in standard position. From 0 degrees to 360 degrees. So basically, just on the Cartesian plane you've been taught, right? If we have to sketch, what's the very first thing we should do? Draw a Cartesian plane and do what to it? Label it. Label it. So, I'm going to go 0 degrees, 90 degrees. Make sure you have the degree symbols. 180 degrees, 270 degrees, 360 degrees. The degree symbol is important because if you don't have degrees, you have radians. Okay, 155 falls in what quadrant? Quadrant 2. Because you always go 1, 2, 3, 4, top right. Makes the letter C. Now 155 is how far away from 180? 155 is how far away from 180? 25. So it's 45 is halfway, 25 is like maybe here-ish. If it's somewhere in this realm, but not halfway, and down here, then you're good. So draw your initial arm and draw your terminal arm. Remember, you have to have both arms. Then you have to have an arrow drawn to it, and you write 155. I may have drawn this one too steeply close to the x-axis. It was a little bit aggressive. Okay. Ish, a little bit. Okay. If I go like this, how much is that? 25. And what is that? The reference angle. Because remember, the reference angle in quadrant 2, or reference theta, same thing. Reference angle in quadrant 2, I always do 180 degrees minus my angle, which gets me 25. Very good. Number 2, it says, given the reference angle and quadrant, determine the angle in standard position. Reference angle and quadrant. So I always draw them because it helps me out. I go 0, 90, 180, 270, 360. And I know that 35 is from the x-axis. So I need to be a little bit less than halfway. So this is 35. Right? I need to reset my board is what I need to do. Anyways, there's an initial and a final. I need this. How do I find it? When you're in quadrant 2, you do 180 minus the reference angle. And what did we get? 145. Okay. B. Doesn't matter where you start, it matters where you end. Those you freaking out, that wasn't going to work out for me. Oh, wait. It's like a game? Is that what you said? I always win. I know. It's okay. Okay. Reference angle of 73 in quadrant 3. So 73 is quite a large angle. 0, 90, 180, 270, 360. What do I know at least? Where is it going to fall between? At the very least. Between 180 and 270, correct? So if your answer is not between those two, you really messed up because you're not even in the right quadrant. Okay? Now we need it from the x-axis. So 73 from the x-axis is approximately like that. It's the bow tie angle, remember? If I drew it up, I would have the bottom left of a bow tie. I need my initial. I need to rotate 0, 0. So it goes the whole way. How do I figure it out? The theta equals, I can just do it here, I guess. Theta equals 180 plus 73, which is 253. One 80, 270, 360. And it's in quadrant 4, so it's 17 just here. So how do we find the angle? Yeah, so we go theta equals 360 minus 17, which is 340. Okay, then we're going to flip to our notes. Go back to our notes where we left off. You guys are doing example 4. There is an angle in standard position with a reference angle of 60. It falls in quadrant 1, 2, 3, and 4. What's the difference? Angles. So reference angle is 60 in quadrant 1, in quadrant 2, in quadrant 3, in quadrant 4. Draw them and tell me what they are. Okay.
Deal for $2.
They're big muffins. Yeah. We're winning. Okay. So, first one. We have a 60-degree angle in quadrant 1. 45's down the middle. 60's a little higher. Boom, boom. Make sure you have initial. Make sure you have a final. Make sure you have a rotating dot. And make sure you have an arrow. What's the cool thing about quadrant 1? The reference angle and the angle are the same. It is easy. This is true. Okay, 60 in quadrant 2. So I need to draw my initial. I need to draw my rotation. And then it needs to be 60 from the x-axis. So it's closer to the y. Arrow. How do I find this one out? 0, 90. I didn't even follow my own rules. I did not label the previous one. It's going to fall between 180 and 90. And how do I figure it out? How do I figure the angle out when it's in quadrant 2? 180 minus 60. So theta equals 180 degrees minus 60. So it is 120. Okay. Quadrant 3. We have 0, 360, 90, 180, 270. 60 in quadrant 3 would be here. Initial, arrow. How do I figure that one out when it's in quadrant 3?
The sugar rush.
180 plus the reference angle. I'm never going to be allowed to let you go get a muffin again. You just fall apart. Okay, quadrant 4. If I draw the 60, still from the x-axis, so it's 60 from the x-axis. Here's my initial. How do I get the angle? 360 minus 60. And I get 300. Then we're going back an example. We're going back to example 3. Example 3 says, determine 3 angles between 0 and 360 that have the same reference angle as 256. So what are we going to have to first do? Find the reference angle of 256, then use it in the other 3 quadrants and get me those angles. Go. Okay, so here we have 256. The first thing we need to do is label 0, 90, 180, 270, 360. We draw 256. Shh. 256 is close to 270, correct? So it's going to be close to 270. It'll be somewhere, probably more than that, but that's okay. Rotate, initial, boom. 256. How do I find the reference angle? In the third quadrant. 256 minus 180. And what do we get? 76. Thanks, all you helpful helpers. Okay, so we get 76. Now we have to go to every quadrant and find out what angle we would get with the reference angle of 76. So in quadrant 1, what would we get? 76, that's the easy one. In quadrant 2, oh my. Quadrant 2, if we drew the reference angle of 76, it's going to be close to the y-axis. How would I find out the one in quadrant 2? 180, yeah. 180 minus 76. So I get 104. Thanks, helpful helpers. Then I need 76 here, which is close to the y-axis. But it's here, it's where I'm starting, and it goes around. How do I get it in the fourth quadrant? Yeah, 360 minus 76. And I get 284. Okay, then we're going to go move down to example 5.
Oh boy. And that would be like example 5.
It's like literally right beside the school.
Oh yeah, it was.
No, look at it. You can see it.
It's cracking into what?
It's like literally cracking into the wall.
Yeah, they do. They make holes in our walls.
There's like 5 of them too.
Yeah, they're vicious. What are you doing? This is not the hard neck.
No,
It's just
no,
Nick,
that's fine.
You're right.
Oh, it's just
You just know.
No.
Are you closing it?
Oh, you scared them away now.
Nick, pull on the back.
Other side.
On the back. Okay. Yeah. Now pull. Oh my God. It's just a heavy blind.
Oh, that happens. Well, you get the hole in the front one.
Yeah, it's just a heavy blind though.
Oh, I don't like it.
Yeah, it's good.
This is really great. I can't see my board, but thanks, guys. Okay. Is our savior. Can we close the?
Jesus Christ.
Is our savior. Nicholas. No.
My hand.
Sit. Sit.
I'm right.
You opened it.
I slowly did.
Yeah, because you were trying. Oh my gosh. Okay. Okay, paying attention because where I'm going to lose you. So, that wasn't worth a freak out. It's just, if you're not paying attention, I will lose you. So, we have given the point -4, 5. If we're given a point, what should we probably do with it? Mark it on the graph. Okay, let's do that first. 1, 2, 3, 4, -4. 1, 2, 3, 4, 5, -5. It's right here. Okay? So here it says, given the point -4, 5, draw the angle in standard position. So that's where the point, it's crossing through this point. So our final arm is going like this. Our initial is still here. Still rotating here. Still doing this. Yeah, they're great. Sammy, Susie, Timmy, all of them. So nice. 0, 90, 180, 270, 360. Okay. What is our problem currently other than the woodpeckers?
We don't know any.
We don't know the reference angle, correct? If we knew the reference angle, how could we solve this? 180 plus the reference angle. So we need to get the reference angle somehow. Going back to grade 10. We always venture back. Yes. So, okay. So, we are going to, we need to find this angle, correct? If we have that little angle, we can just add it to 180, boom, have our center position. We agree? Well, this coordinate, if you draw it, we always draw it towards the x-axis. We always draw it towards the x-axis because that would make a bow tie, correct? We're always making bow ties, not hourglasses. We're making bow ties. Bow ties for life, yes. Okay, so if I take that triangle out, I'm going to take the triangle out here and we're going to draw it. So it's like this, it's like this, it's like this. This is my angle. How can I label anything else? The coordinate helps me. How far across is it here? -4. How far across is it, or how far down is it? -5. I don't know the hypotenuse. I could find it, but I don't need it because I just need an angle. When I have two sides, can I get an angle? Yes. Okay. So, what are we given? Well, we're not given the hypotenuse. The hypotenuse is always what's across your 90. So I don't have the hypotenuse. Your opposite and your adjacent will change depending on what angle you're looking for, correct? And we're always looking for the inside angle because I just took that triangle out here. So this one, which one is opposite that angle? The -5. Which one is adjacent to that angle? -4. Oops. Okay? An O and an A. So what trig ratio uses O and A from SOHCAHTOA? 10.
Yeah, I'm like that.
So we have tan theta. It's SOHCAHTOA, opposite over adjacent. And we're going to turn these to x's and y's in a little bit, but for right now we'll use some grade 10 stuff till we understand it really well. So we can use x's and y's instead of o's and a's because this is on a Cartesian plane now, correct? So my 4 would actually be an x and my -5 would be a y, right? So we can actually use them now. But we're not going to. We're going to stick to our grade 10 stuff till Monday. So tan equals opposite over adjacent. So I'm going to go tan theta equals -5 over -4. Now the negatives actually cancel and I just get positives, correct? Now how do I get theta by itself? Well, there's a tan stuck to it. How do I get rid of tan? Tan inverse, yes. So we're going to go tan -1 both sides. Now your calculator needs to be in what? Degree mode. If it's been reset, it will be in radian mode. In grade 12, we will float back and forth between radians and degrees. It won't matter what you're in. You're going to have to change it depending on if we're in radians in the question or degrees in the question. But for grade 11 for now, we're in degrees. So make sure your calculator is in degree mode. So go mode, and then over, move down, and then over to degrees, right? And then hit enter. So go second tan 5 divided by 4.
Wow.
It's 51 degrees.
Yes.
So our reference angle is 51 degrees. Remember, you need to be mode, and down here you need to go to degrees and hit enter. Then second mode gets you out of that screen. Then we can go second tan, because that's tan inverse, of 4 divided by, was it 4 divided by 5 or 5? 5 divided by 4. And you get 51.34, blah, 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 blah. It will say in the test. So it'll either say it's near whole number or 10, and you have to do what it says. No. It's rounding rule is always a great time in math.
What do you mean?
Okay. So, we know now that we took this triangle here out. Here's the red triangle we just pulled out. Correct? And we just found out that this angle is 51. So this here is 51 degrees. So how do I get the standard position angle, this green angle? I'm going to go theta equals 180 plus 51. And it's 231. So often where people get stuck on these questions is the grade 10 math of it. Okay? So remember, if we're given a coordinate, the trig ratio we'll always use to find our reference angle is going to be tan. Because if we're given a coordinate, we're always going to be given the opposite and the adjacent and not the hypotenuse every single time. So for all of these, when you're given a coordinate, you're going to find your reference angle by using tan. Okay? So I'm going to get you guys to try this one of what's different. So we plot -6 and 3. So it's 1, 2, 3, 4, 5, 6. 1, 2, 3. Remember that it's x, then y always. So we're actually in quadrant 2. -6 and 3. We draw our final arm through it. And our initial. And we know to find the angle in quadrant 2, right, Raymond? We're going to do 180 minus the reference angle. So, we're paying attention? The reference angle is always the bow tie angle, so it's going to be this triangle here. This is the angle we're finding. We agree? So I'm going to go off to the side and I'm going to draw that triangle because it's easier to visualize if it's not sitting in the Cartesian plane because you guys have never done that before. So here we have a -3, and here we, or sorry, +3, and here we have a -6, because that's -6, that's +3. We agree? When we're given a coordinate, it will always be tan. Now, if you plug this in, and this is something you're going to need to remember. If I had it in quadrant 1, what do we know about the reference angle in quadrant 1? The angle and the reference angle are the same. We agree? So if I always do my trig ratios to the positive, even if they're negative, they'll get me the reference angle. So if I do this one, it would be tan theta equals opposite, which is 3, over adjacent, which is -6, because this is opposite and this is adjacent. However, if you do that, you're actually finding, you can be finding totally different things, not the reference angle. If I want the reference angle, it doesn't matter if it's 3 divided by -6. It worked over here because it was a minus divided by minus, like a negative divided by negative, correct? And it turned positive. If you want to find the reference angle, you always just do the positive of the fraction. It doesn't matter if it's negative or positive. You always do tan inverse or sine inverse or cos inverse of the positive. So for reference angles, you always do the positive because then it will plop it into quadrant 1, which is always the reference angle, correct? And all we need is the reference angle. So I'm actually going to go theta equals tan -1 of 3 over 6. I don't care that it's negative. The negative got me into that quadrant, but the reference angle I can just do by doing the positive. And what do I get? 20, is it 7? 27 degrees. So this here is 27 degrees. So how do I actually get my angle in standard position? 180 degrees minus 27 degrees, which gets me 153. Okay, let's look down here. These ones are 4, 4, -4, 4, negative, -4, -4, 4, -4. The different negatives are going to put them in different quadrants, but are they going to have different reference angles? No, because it's going to be 4 divided by 4. It's negative 4 divided by 4. I'm still doing 4 divided by 4, right? So actually, they're all going to get the exact same reference angle. The negative signs just place you in different quadrants. Okay? So try this one out. Example number 6. So we're going to do this one first. It's at 4 and... Stop talking. 4... Stop. 4 and 4. Which is here. And then it's going to be in this quadrant here. And we found that tan theta of 4 over 4, theta equaled what? Tan of 1 is 45. So these are all going to have reference angles of 45, and we know that. Yeah. Yes. They're all going to... Can I go pee? Yes, you may. Anything else, I say no. Okay, good. Good luck. All right. So we have 45. So we have 45 degrees here. You think that there's way worse coming out of your mouth sometimes. Okay. So we go negative 4. No. 1, 2, 3, 4. 1, 2, 3, 4. No. And we have 45 degrees here. So how do I get this angle? 180 minus 45, which is 135. This one is negative 4, negative 4. So it goes like this. So we're going to go 45 here. So what am I going to get here? 180 plus 45, which is 225. Then this one is 4, negative 4. Here's your 45. So how do I get this one? Which is? Okay, your homework. Oh, no.
Oh.
Oh. Okay, it's on page 83. That's the homework from yesterday. We're adding to it. We're going to add
We have numbers. Yeah.
Oh, we're not close. I go for no more.
No, because I don't watch the ads on Instagram.
Okay, page 96. It's not 83. Page 96.
Fire.
You joined it.
Fire, fire, pepper fire.
Immature. Okay. I want to add extra.
I'm just teaching. How's the pee?
Glad you survived. Negative. Oh my gosh. Number 1 and 12.
Oh, yeah.
I gave you oodles of time to finish those. Oodles.
Ruby 8.
No.
One.
Oodles.